Alright, so this video is going to go over square root and cube root functions, or the graphs of square root and cube root functions. And so the way that we graph these things is very similar to the way that we've been graphing functions all year long. We'll start with a square root function. And for a square root function, you're going to have something very basic like y equals the square root of x. As you think about it, normally when it comes to a function, you plug in x values and out come y values. So if I were to make a table like this, I would pick x values that I could use, and then I would do the square root of it, and I would get back the y value, and then I'd plot the points on the graph that we have here. The one thing that's interesting about a square root function is remember that you can't square root negative numbers. So actually the first x value that you could start with in this problem is 0. And so then when you square root 0, you'd get 0. And you could do 1, and then you'd have 1, because the square root of 1 is 1. Then if you want to just keep going, you could do 2, and that would be the square root of 2, and we don't know it. I'd have to get a calculator. If you tried 3, it'd be the same situation. You'd have the square root of 3. But then when you get to 4, what's the square root of 4? The square root of 4 is 2. And so as I'm graphing square root functions, I might think about picking x values that make my life easier rather than having to graph on this coordinate plane the square root of 2 for a y value or the square root of 3. It might be easiest to just go with 0, 0, 1, 1, and 4, 2. And so I'll plot those points, 0, 0, 1, 1, 4, 2. If you think about another x value that might work, I agree with you. I know you were thinking about it. It's 9, right? So 9, if you plug in 9 there, you would have 9, 3. And so then I could put that point here. And so a square root function graphs this kind of arc, if you will, that doesn't go all the way to the left and all the way to the right. It just starts at a singular point. We'll call this the starting point. It starts at a singular point, and then it goes to the right or the left, depending on the kind of transformations that are taking place in the square root function. So it's kind of like half of a parabola on its side. Alright, so let's take a look at another kind of square root function. So here we go. Let's take this and move it right here. So we have a graphing form for square root functions that looks like this, and it's going to look very similar for what you call it, cube root functions. So it's y equals a square root of x minus h plus k. And if you know what our transformations do, you know how this affects it. But the only thing I'll say here is that the starting point that I just pointed out, the starting point is at hk. And so if you have a function like this, y equals the square root of x plus 1 and then minus 2. If you want to graph that and say you didn't have a calculator, the first thing you would look for is you would look for the starting point. And for us, remember when finding h, it's the opposite of what you see in here. So think of what would x plus 1, what would make x plus 1 equal 0, and that would be negative 1. And then out here is your k value, and so that'd be negative 2. So our graph is going to start at negative 1, negative 2, right there. To figure out the rest of the points, basically what you want to do is you want to pick x values, probably 2 more x values I would ask. Pick 2 more x values that will allow you to make perfect squares. So if you look underneath the radical, it's x plus 1. So think about a number that you could plug in for x that when you plug it in, it would create a perfect square. So I'm going to say that 3 would work because 3 plus 1 is 4. And if you think about it off to the side over here, 3 plus 1 and then minus 2. So 3 plus 1 is 4. Then I'd have the square root of 4 minus 2. Square root of 4 is 2, and then 2 minus 2 is 0. So now I'll have another point at 3, 0. Another perfect square that you might not normally think of is 1. 1's a perfect square. So what's an x value I could plug in for x that would get 1 underneath the radical? It'd just be 0. I could plug in 0, and so 0 plus 1 is 1. The square root of 1 is 1. Here, maybe I'll write it down to help you out. 0 plus 1, and then minus 2. So square root of 1 minus 2. Square root of 1 is 1. 1 minus 2 is negative 1. So then I'll have negative 1 for my y value. So 0, negative 1 is another point, and there's our graph. Okay, so we'll just have 3 points, the starting point plus 2 more, and then we'll graph that, and it'll open up that way. Now, of course, I'm going to ask you for the domain and range. So remember, the domain is how far to the left and right does the graph go. So for the domain, the farthest to the left that it goes is, right, negative 1. So we're going to say bracket, negative 1, and then it moves to the right forever. So that's going to be positive infinity. With the range, and that's not a bracket on the infinity, that's parentheses. With the range, it's how far down does the graph go to how far up. So what's the lowest point? The lowest point is at negative 2. So bracket, negative 2. And then it's going up, but it's going up slowly. So we'll say it's going up, and that would be positive infinity. The graph's going up, so the y values are becoming greater and greater and greater, and that's a parentheses. Now remember, the bracket means that it can equal it because we have a point there, our starting point, and so that's why we're using a bracket. Parentheses means it cannot equal that graph or that value, and so infinity, you can't equal infinity. I'm actually going to stop the video there, and we're going to call this video we're just going to call this video square root functions. So we're actually just going to only talk about square root, and I'll make a new video for cube root functions. Alright, have a great day.